Most things get what they need to stay alive by converting energy from a form they can't use to one they can. The same principle powers almost every aspect of our lives. We convert the energy stored in coal and natural gas by burning it to make heat and electricity, and use oil to make things and get them where they need to go. These fossil fuels are really just concentrated forms of energy that started with the sun. When it comes down to it, coal and oil are just plants and animals that got all rotten and gross, but eventually turned into something pretty useful. As it turns out, the very same decay process that made fossil fuels is at work in landfills across the country. When trash decomposes in the landfill, it gives off methane, the same stuff that makes up natural gas. We can catch that methane and burn it to create heat and electricity. Chemistry. So imagine taking stored energy from all kinds of biomass like
sawdust,
coffee grounds, grass, wood scraps,
food scraps,
trees,
and changing it into fuels, just like the ones we already use. At Arizona State University, researchers want to farm algae for fuel. So, Emil, what are you working on here? What is this big tub for?
Now, this is a pond reactor. Algae is being grown in order to produce oil. As you can see, there are several different size of ponds here where different kinds of algae are being put in experiment.
This works because algae contains oil we can convert to fuel, the same way we convert the oil we get from the ground. You can do something similar with restaurant grease too. Delivery vehicles powered with waste oil? Smells like French fries. There's one big problem: cellulose. It makes flower stems rigid and tree trunks sturdy. It's tough stuff, but it's packed with energy. To create biofuel from plants, you first have to convert the cellulose to sugar. To learn more, I visited Garrett Sewin, a scientist who studies leafcutter ants in Cameron Curry's lab at the University of Wisconsin.
So what we're really interested in is learning from nature and understanding how these leafcutters have optimized this process of degrading all of that plant biomass into the simple sugars.
If we can convert cellulose into sugar on a large scale, we've solved a big biofuel problem, because we're already pretty good at the next step, which is to take the sugars and ferment them into ethanol for your car. The team Garrett works on hopes the ants can show us a thing or two about energy conversion. Leafcutter ants are farmers. They cut leaves and feed them to a fungus they grow for food. Large colonies can go through as much as 800 pounds of biomass in a year. And in the end, almost everything is broken down, even the cellulose. The Curry lab doesn't know exactly how this happens, but they're hard at work looking for the answer.
We took material from the top of the gardens, and then we took material from the bottom of the gardens, and we just measured the amount of cellulose that was present inside of that plant biomass. And so part of what we're doing now is we're going through and trying to find the microbes that are responsible for this degradation, be it the fungus that the ants grow for food themselves or bacteria that also live inside of this microbial community.
So we got the bacteria out of the dirt.
Exactly.
Now what happens?
So now what we want to do is we want to test to see whether or not they can eat cellulose. So here is our cellulose testing station, and I'm going to introduce you to Miss Laura, who is a student in our lab. So Laura, why don't you explain a little bit about what you're doing?
Well, once we get the bacteria in isolation from the fungus gardens, we plate them on cellulose media called CMC to see if they can grow. So if they're able to grow on this media, we know that they probably can degrade cellulose.
Once the Curry lab figures out what's breaking down the cellulose, industrial researchers can begin to produce giant vats of biofuel. But this process takes time, and there's a huge demand for fuel. Engineer George Huber at the University of Massachusetts Amherst uses chemistry and heat to turn waste from a sawmill into bio-oil and gasoline.
Okay, so right here we have some sawdust that we got from Cole's lumber. This is our feed to make green gasoline. Our first step is to put this in the hopper.